Now we shall look at merge sort. It is also a sorting algorithm, and merge sort is better compared to the insertion sort, and it is even sometimes better compared to the quick sort. So merge sort is supposed to be good in terms of the time complexity. So before going to discuss about merge sort, the heart of the merge sort is a procedure called merging. So let me talk about merging. Entire merge sort depends on a procedure called merging. Let me talk about merging first, and then I'll talk about merge sort. Okay, so just to explain you what merging is, if input is given in an array such that some part of the array is, let us say the array is containing like this 1, 5, 7, 8, and the other array and the other part of the array is containing 2, 4, 6, 9. Okay, so now in this array one, let us say indexes are like this 1, 2, 3, 4, 5, 6, 7, 8. Okay, in this array 1 to 4 are sorted and 5 to 8 are sorted. Okay, listen to this. Now 1 to 4 are sorted and 5 to 8 are sorted. Now what I want to do is I want to sort these two lists. Actually this array is containing two lists. One part is from 1 to 4 and other part is from 5 to 8, right? Now we contain two lists. Now these two lists are already sorted. Now the result has to be again a sorted list which contains all the elements. So how does this algorithm work is, whenever any array is given A in such a way that from P to Q it is sorted, and from Q plus 1 to R it is sorted. That is how P to Q and then Q plus 1 to R. If these two lists are sorted, now I want to merge them into a single list which is sorted. So how does this algorithm work is, first I'll create a new list called L, which will have exactly the number of elements from P to Q. Its size should be exactly P to Q plus 1, which means 1, 2, 3, 4 plus 1, 5, right? That is what we are doing. So now 5 elements will be there in this L, and again I will create one more list called R, and in this also how many elements are there from Q to R plus 1, which means here there are 4 elements, therefore 5, 1, 2, 3, 4, 5. So what is the first step? They are giving you a list which contains a sorted list and a sorted list in an array. Now we are creating two separate arrays. One array is containing the first, one array size is exactly the size of the first list plus 1, and the other array size is exactly the size of the second list plus 1, right? And the next step is you copy all of them, all the one list from to L and other list to R. So in order to copy one list to L, I'll copy this 1, 5, 7, 8, and the other list is 2, 4, 6, 9. So how much time does it take for you to copy the elements? It is nothing but order of n. If there are totally n elements, then to copy them the time taken is order of n. Fine. Then the next step is, at the end of every list you write infinity. So infinity is practically infinity is not possible, but then by saying infinity I mean you put a very large number. Okay, whatever is possible by the data structure which is used to hold these numbers. And next thing is, into this list, this one, we are going to copy everything, which means into the list A, into the array A, 1, 2, 3, 4, 5, 6, 7, 8. So all the elements are already present. I am going to overwrite it. So into this element 1, 2, 3, 4, 5, 6, 7, 8, into the same array A, the given array, I am going to write all these elements in the sorted list. So what I do is, I'll take a pointer, let's say 2 pointers, one is called I and other is called J, right? And then I'll take a pointer K here, right? Now I indicates the element that you are examining in the left list, J indicates the element that you are examining in the right list, and K indicates the element that has to be filled in the array, right? The given array. Now I'll compare this left list element I and right list element j. Whichever is lesser, I am going to write it into the array. Okay, and I'll increment it. Since this is already written, I am going to increment this, and anyways k is going to be incremented to this. Now k is going to point to second one. Then again I compare these two, right? List, left list and right list, the corresponding elements 2 and 5, which is less, 2 is less, therefore I am going to write 2 here and I am going to increment it. And again these two elements are going to be compared. So which is lesser? 4 is lesser. I am going to write 4 here and again increment it, right? And now 4 has to be incremented, right? Then 5 and 6 are compared. Which is lesser? 5 is lesser. Therefore write 5 here and you increment it, right? And now 7 and 6 are compared. Which is lesser? 6 is lesser. Write 6 here and you increment it. Then 7 and 9 are compared. Which is less? 7 is lesser. Write 7 here and you increment it. Then 8 and 9 are compared. Which is lesser? 8 is lesser. 8, write 8 here and then you increment it. Now infinity and 9 are compared. Which is lesser? 9 is lesser. Write here and stop it. So that is the entire algorithm. So what is the algorithm going to do? This merge procedure. The merge procedure is going to take the entire list and it is going to create two lists. So in one list I am going to copy the first ordered list, first sorted list, and in the second list I am going to compare the second sorted list. And now after copying them, I am going to write everything back into the original list in such a way that the entire list will now be sorted. If you check this, it is sorted, right? So just I'll explain you the code here. First of all, A, P, Q, R. So merge is going to get an array A in which it is going to get 3 pointers. One is P, one is Q, one is R. This P represents from P to Q it is sorted, and from Q plus 1 to R it is sorted. That is what PQR represent. Okay, and now you just count how many elements are there in the first list. The number of elements in the first list are these many, Q minus P plus 1, Q minus P plus 1, and the second element contains, and the second list contains R minus P. So these are the number of elements in the first list and the second list. And now you create two lists. So I am going to create two arrays, one array by name L and one array by name R, in such a way that these lists are able to accommodate how many ever number of elements are there in the first list plus 1, and how many ever number of elements are there in the second list plus 1, right? So why that plus 1 space is reserved, so that I could put the infinities at the end, right? And now this for loop is used to copy the first list into the left array, and this for loop is used to copy the second list into the right array. Therefore I am going to copy the first list and second list into the arrays, right? And the last element is filled with infinity. The last element is filled with infinity, right? And then I start comparing. So I'll start with I equal to 1, j equal to 1, which means I start with this pointer 1 and this pointer 1. And now for k equal to p to r, which means for k equal to p to r, so p to q and q to r, which means the entire elements. I am just seeing, comparing between left and right, which one is less. Let us say if the left element is less, I am going to write it down, right, and then increment it. If the left element is less, then I am going to copy that left element into the array and increment the left side pointer. If the right element is less, I am going to copy the right element into the array and increment the right pointer. Anyways, you have to increment, yes, k is going to be incremented at every step. Understand this? So I am going to compare these two elements, whichever is lesser I am going to write it and then increment it. K is how we are going to be incremented, and next time I am going to do this, right? So what is the total time complexity for this is, first of all, in order to copy these two lists into these new lists, the time taken is order of n, right? And how many copies and how many comparisons are required is, understand this, if the total number of elements in the array are n, then in order to write one element into the array, I have to do one comparison. Therefore, if there are n elements, then I have to do n comparisons, plus every element after compared, one of it has to be written down. Therefore, there have to be n element comparisons and n copies. So again it is going to be order of n, right? So first thing is, for copying the elements into two different lists, time taken is order of n, and then for copying the elements from the two different lists again back to the given array, it is going to take order of n. Therefore the total time complexity required by this merge sort is order of n, right? That is the heart of the algorithm. So the questions on this might be, given two lists, two sorted lists, one list is of size n and other list is of size m, how much time does it take to merge them into one sorted list, right? So what will be the size of the final list? Size of the final list will be n plus m, right? So n plus 1 elements have to be written from here to here. So for writing one element into this, I need one comparison and one movement. Therefore total number of comparisons and movements required is order of n plus m. And one more thing is, remember that if they are giving you this n elements in one list and m elements in other list, you have to have space, extra space, which is equal to n plus m. Okay. So time complexity is going to be whatever is the size of the input given, which is nothing but order of n. But the space complexity required is whatever is the size of the input given, we are again creating nearly elements of that much size, isn't it? So the space complexity required is order of n and the time complexity required is order of n. The reason is, whatever the elements are given, input is given in this array, I am again writing all the elements into two lists and these two sizes are nearly equal to n. Therefore, in order to solve this problem, I need exactly, at least order of n size, extra size. So this merge procedure is also called out of place procedure. The reason is, we are copying all the elements out of their places and then solving them, right? So you might get a doubt, why are we adding infinity at the end? I'll just explain you. If you understood this, the time complexity is order of n and space complexity is order of n. Now I'll explain you why should we add the infinity at the end. I'll take some other example and I'll explain you that. Let's say one list is, or the given array is like this. One, two, three, four, or given array contains 10, 20, 30, 40, and then the next elements are 1, 5, 6, 9. Okay, and this is A, and P is the beginning of one sorted list and Q is the ending of that sorted list, and Q plus 1 is the beginning of next sorted list and R is the ending of it, right? Now this means that from P to Q I have one list which is sorted, and from Q plus 1 to R I have other list which is sorted. Now what is the size of one list? 4. Therefore you have to create an array which is of size 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Right? And I am going to copy 10, 20, 30, 40 in this, and in the fifth element I am going to copy infinity. Now I'll tell you why this infinity is used. And now in the other one, 1, 5, 6, 9, and now infinity is added at the end, right? So now you will start with I here and j here, and let us say this is the array A itself. 1, 2, 3, 4, 5, 6, 7, array A itself. Whichever is lesser I am going to write here. Which is lesser? 1, right? And which is less? Now 1 will be incremented, and now which is lesser? 5. This will be incremented. Which is lesser? 6. This will be incremented. Which is lesser? 9. This will be incremented, right? Now you are going to see that one entire list has been copied here and the other list is still there. If this other list has to be copied onto this element and onto this list, that is why I have to have infinity at the end. Finally infinity will be compared with 10. So this having infinity at the end will ensure that if one list is over, then the other list will automatically get copied onto the A, right? Now by comparing infinity with 10, obviously 10 will be copied, and now comparing 20 with infinity, 20 will be copied, comparing 30 with infinity, 30 will be copied, 40 with infinity, 40 will be copied, right? Now by having infinities at the end without doing any modifications to the code, if one of the list is over, other list will automatically be copied. You need not check if one list is over, then you have to copy the other list and all. This just to simplify the matters. If you don't like having this infinity at the end, maybe you might have to just change the code in such a way that you have to check if one list is over. If that is the case, you have to copy the remaining list completely. That is the only reason why infinity is added. Anyway, the important point is, for merging two lists, if extra space is given, then only the time complexity is going to be order of n. If extra space is not given, then the time complexity might increase, right? If extra space is not given, then you might have to apply some other sorting method. Merging method might not work. Therefore, merging method needs, if the input is given in n numbers, then we need an extra space. Then in order to copy all the elements from the given list to the next list, we have to have order of n time, and the space complexity is order of n. Okay. Now we shall see how to use this merge method in order to sort the entire array. Okay, that is called merge sorting. We shall see it now. So we have already seen the merge procedure, how to merge two sorted lists into one single list. Now we shall see merge sort. Okay, so what is this merge sort algorithm is? It actually falls in a category called divide and conquer. So divide and conquer means, if I have any problem of size n, divide and conquer says that you divide the problem into two subproblems, okay, or any number of subproblems, and then you solve the subproblems first, and then you combine the solution. Okay, the same thing is what is merge sort is going to do. In merge sort also, in order to sort a list of size n, or in order to sort an array of size n, it is going to divide the array into two halves, and it is going to sort the first half first, and then the second half, and then it is going to merge the solution, okay, into the final answer. So that is how merge sort is going to work. So merge sort, given an array A, which we have to sort elements from P to R, then we are going to find the midpoint, and now we are going to sort the array from the starting element P to the midpoint, and then from that next to that midpoint to the end, which means we are going to find out the midpoint first, we are going to sort it from there to there, and then from the midpoint to the next one, and then we are going to merge it. So instead of talking about the algorithm, explaining the algorithm, I'll better take a example and I'll explain you. I'll take an example of small size. Let us say I have an array of size 6, right? And merge sort is different and merge is different. See this, merge sort is going to call, one is merge sort procedure and merge sort procedure, and the other one is merge procedure, and all this this merge sort and merge both are different. So let's say I have 6 elements like this. 6 elements are okay, these 6 elements, and now I have to sort them, and all these 6 elements are present in an array called A, and they are numbered, and the indices are from 1 to n. Let us say this is 1 2 3 4 5 6. Okay, now this array is present like this. Then how does the merge procedure work is, merge sort work is, so in order to sort from 1 to 6, I have to call merge sort on A. A is already implied, therefore I am not going to write A. I am going to call it from first element to sixth element. Okay, then what is happening is, see, every function call is going to call 3 functions, therefore I am going to write a tree with three children. Okay, and now what are the 3 children? First one is merge sort is going to call, first it is going to find out the middle. So what is the mid value for 1 and 6? 1 plus 6 by 2 is 3.5, and if I take the floor, it is going to be 3. Why? The midpoint of 1 plus 6 is 1 plus 6 by 2, it is 3.5, and if I take the floor, it is going to be 3. Therefore, I'm going to apply merge sort from 1 to midpoint, which is 3, and then I'm going to apply merge sort from 4 to 6, the remaining elements. And then what is the next one? Once this list is sorted, and once this list is sorted, I got two sorted lists and I'm going to merge them, right? Therefore, it is going to be merge of 1 to 3 and then 6, 4 to 6, right? So all the merge sort I am going to write as ms. Ms means this merge sort calling, and m means merge procedure calling. And what does this one do? This one will also call three sub functions, right? So what are the functions? One is it has to merge three functions. What are the three functions? One is it has to find out the midpoint. What is the midpoint of 1 and 3? 1 plus 3 by 2, which is nothing but 2. Then merge sort of 1 comma 2, and then merge sort of 3 comma 3. So from 1 to 3, if I sort 1 comma 2, then what is remaining? Only 3, third element. That is why that one. And then finally, whatever result we get, we have to merge, right? We have to merge these two, which means I have to merge from 1 to 2 and then 3, isn't it? 1 to 2 is sorted and then 3 to 3 is sorted. That is why I have to merge them. Then what about this? Again, find the midpoint, right? So how can I find the midpoint? Merge sort of, what is the midpoint of 1 and 2? 1 plus 2 by 2, which is nothing but 3 by 2, which is 1, right? So merge sort of 1 comma 1, and then merge sort of 2 comma 2, and then you have to merge list from 1 to 1 with 2 to 2. That is why I am calling this. And what about this one? This merge is fine. Merge is not going to call anything. Now what about this one? Find out the midpoint. What is the midpoint? 4 plus 6 by 2, which is nothing but 5, which means I have to merge sort of 4 comma 5, and then I have to apply merge sort on 6 comma 6, isn't it? Why? Because it is already over. Then the 4 to 5 is sorted and then 6 to 6 is sorted. Therefore, you have to simply merge them. I have to merge 4 to 5 with 6, isn't it? I have to merge the list from 4 to 5 and then 6 to 6. So you can see how am I writing these numbers from that algorithm, right? And then what about this? I have to apply merge sort on 4 comma 4, and then I have to apply merge sort on 5 comma 5, and then I have to merge 4 to 4 and 5 to 5, right? So now you just see how I got all this. Every merge sort is going to call 3 sub functions. That is why I am going to have for every merge sort 3 callings. But then merge is not going to call anything else. Therefore, merge is going to end. And what about this 1 1 2 2 3 3 4 4 5 5 6 6 is whenever p is less than r, then only we are going to do this. But in this case, p is equal to r, p equal to 1, q equal to r, right? P and R both are equal. P and R both are equal. Therefore, this is where you are supposed to stop. Only if P is less than R, which means if 1 is less than 2, we go for the calling. If P equal to R, we are not going to call anything else. Therefore, they are going to halt here, right? So, merge procedure is going to halt wherever, whenever it is, called. But then merge sort is going to halt only when P equal to R. That is why merge sort is going to halt at 1 1 2 2 3 3 4 4 5 5 6 6, right? Now let's see what happens. Then what is the order in which all these functions will be called is just traverse it top down, left to right. I am traversing like this, which means they are saying that I have to apply merge sort on 1 to 6 elements, right? So let us say all these 6 elements are these, right? 9 6 5 0 8 2. Let us say these are the elements. Now 1 to 6 elements are these. It is saying that I have to sort all the 1 to 6 elements. In order to sort 1 to 6 elements, it is calling sort 1 to 3, which means You have to sort these 3 first. So it is just saying that by the time I finish this, I'll be able to sort 1, 2, 3. But then this is the first time you are visiting it, which means the function is just now called. The function is not yet done. Now this function is calling merge sort of 1, 2, which means it is saying that in order to sort this, you have to sort these two. And now this function is saying merge sort of 1, 1, which means in order to sort this, you have to sort this first element 9, and it is done. It is done, right? Why? This is the last time I am saying it. Whenever I am saying a note for the last time, you can see, you can think that that computation of the function is over. Now the computation of 1, 1 is over. It means the list which is containing first element is already sorted. Then we are going to go to the next function, which means it is calling 2, 2. This one, this element, right? And by the time I finish it, it means that it has already sorted the list which is containing the element 2, 2, which means 6. Therefore, by the time I reach here, there are two lists. One list contains the first element and the other list contains the second element, and both of those lists are already sorted. The reason is merge sort is supposed to sort them. So, and moreover, every list which is containing one element is already sorted. So by the time I reach here, I have two lists which are sorted. And now I am calling merge. This merge is called to sort the list from 1 to 1 with the list 2 to 2, which means this is supposed to sort, or this is supposed to merge these two numbers. If I merge these two, what do I get? 6, 9, right? So by the time I reach here, it means that I am going to merge 6 and 9. I am going to get 6, 9. And this is the last time I am going to visit 1, 2, merge sort of 1, 2, which means by the time I reach here, the array from 1 to 2 is already sorted, which means the array from 1 to 2, which was containing 9, 6 elements, is now sorted as 6, 9. That is the meaning of it. And now this one is saying merge sort of 3, 3, which means you apply sorting on 3, 3. So any list containing only one element is already sorted, right? That is why it is not doing any work. By the time I finish this, which means by the time I leave it, it is already sorted. Then by the time I reach this, see this, one list from 1 to 2 is already sorted, and other list from 3 to 3 is already sorted. And now this merge is saying that you merge 1 to 2 list with 3 to 3 list, which means you merge 1 to 2 list with 3 to 3 list. That is the meaning of it. This function means you merge 1 to 2, which is already sorted, with 3 to 3. So if I merge these two, what do I get is 6 will be compared with 5, therefore 5, and then remaining list 6, 9, right? So by the time I finish merging, this is the list I got. So therefore, by the time I reach here, I am visiting the merge sort of 1, 3 for the last time. What is the meaning of it? It means that the list containing 1, 2, 3 elements inside the list from the indices 1 to 3, they are already sorted. Listen to this, see this. Now the list containing 1, 2, 3 elements, they are already been sorted, isn't it? Initially it was containing 9, 6, 5, but now they contain 5, 6, 9. Therefore, by the time I leave this, I got a list which is from 1 to 3, which is already sorted. Now I am hitting this, right? I am just starting here at this point, which means now I am here, which means I am about to sort the array from 4 to 6. I didn't sort it yet, I am just about to sort. So it means that I have to sort the array 4 to 6, right? And this is calling the function 4 to 5, which means in order to sort the elements from 4 to 6, you have to sort the elements from 4 to 5, right? And now this is calling the function merge sort 4, 4, which means in order to sort this 4 to 5, we have to sort the 4, 4. That is the meaning of it, okay? And now we hit the next element. This element is saying that in order to sort, we have to sort 5 to 5, which means this element. By the time I reach here, I have already seen the list containing 4 to 4 and I sorted it. Why? Because it is only single element, that is why nothing to be done, but it is already sorted. And by the time I reach here, it means that I have already seen the element 5 to 5, which is also sorted. Now I'm saying the merge procedure. Merge procedure is saying that 4 to 4 is already sorted and 5 to 5 is already sorted. You merge those two, which means these two. 4 to 4 and 5 to 5, they are already sorted, we have to merge. If I merge these two, what do I get? So 0 will be compared against 8 and 0 will be written and then 8, right? So therefore 4 comma 5, I get a list of 4 comma 5 which is sorted. I am leaving this merge sort of 4 comma 5. At this point I will be sure that the list containing 4 comma 5 is already sorted, right? And now I am seeing merge sort of 6 comma 6, which means we have to sort this element 6 comma 6. Since it is a single element, is already sorted list, right? And now by the time I hit this, it is merging 4 to 5, which means 4 to 5 along with 6 to 6, which means this one. So these two lists have to be merged. That is the meaning of it. How can I merge them? Which one is lesser? 0 is lesser, and then which is lesser? 2, and then which is less? 8, right? So by this merge procedure, I got this 0 to 8 list. Now by the time I reach this, right? So what is it? Merge sort of 4 comma 6. By the time I reach this, I'll be sure that the list containing 4, 5, 6 is already sorted as 0 to 8, isn't it? The list is sorted. And by the time I reach this, the list 1, 2, 3 is sorted, right? Now we have two lists. This merge is given the task that, see, from 1 to 3 it is already sorted, from 1 to 3 it is already sorted, and from 4 to 6 it is already sorted. Now we have to merge these two, right? Which means this function, it has to merge 1 to 3 with 4 to 6. How will it merge it? Comparing the first two elements, which one is lesser? 0, therefore 0 will be copied, right? And then comparing first two elements, which one is lesser? 2 will be copied, and then 5 and 8 are compared, which one is lesser? 5, therefore 5 will be copied, and then 5 is copied, and then 6 and 8, 6 will be copied, and then 8 and 9, 8 will be copied, and finally 9, right? So this is going to merge it all. Finally, when I visit merge sort of 1 comma 6, at this point I can be sure that the entire array starting from 1 ending at 6 is already been sorted, right? So this is how this merge sort is going to work. So in fact, if you observe it, how it is going to work is, the basics is this: it is going to divide the array until we are going to get the smallest list. The smallest list is nothing but list containing single element. And moreover, any list containing one element is already sorted, right? And now we are taking two such lists and we are merging them. So it is nothing but dividing the entire problem into such a small problem that every problem will contain only one element, and one element list is already sorted. We take two such sorted lists and we apply the merge, right? And the merge is the actual procedure which is doing some work here, right? And merge sort procedure is simply used to divide the problem, right? And now this is how we trace out the example and see it. Now I want to find out the space complexity. What is the space required by this? So extra space is required, yes. So don't worry about this P, Q and R. They are constant time. Extra time is required for merging. Why? In order to merge two lists, I need to create a different list and then I have to copy into it, right? Therefore, every merge procedure is going to take extra space. But then if you observe it, whenever I am working on one merge procedure, I don't need to work on the other merge procedure simultaneously. Therefore, if I create a global array, one global array which is containing n elements, I can use this rough space whenever required. So just by creating one more array, all the merge procedures can be made to refer to this by creating it globally, right? So the extra space required by the merge is going to be order of n, that is for sure. But then what is the other extra space required is for the function calling for recursion, which means inside the recursion stack, how much extra work or how much extra space do we need? In order to analyze this, first thing is we have to find out what is the total number of function calls made, and what is the order in which they are made, and what is the total height of the stack we needed, right? So if you see this, how many function calls are made is, I'm just writing them. So first function call made is this one, and the second function call made is this one. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so totally 16 function calls are required, and these function calls are made in the order I have shown you, so according to the numbers, right? So if there are 16 function calls required, then do we really need a stack which has a depth or height of 16, which means should I push all these activation records of the function calls one upon other so that the stack height becomes 16? It turns out that the height of the stack required by the recursion stack is actually equal to the height of the tree, or the number of levels in the tree. See this, in this level, first level, we have only one function call. Therefore in this stack, in one level I need only one, this one function call will be pushed onto the stack. Okay, I'll take the stack and I'll show you. See this, what happens is, initially function number 1 will be called, therefore its activation record will be pushed here, and then function number 2 will be called, therefore its activation record is pushed here, 2 is pushed, and then 3 is called, 3 is pushed, 4 is called, 4 is pushed, right? And now at this point 4 is over, therefore 4 will be popped off, right? And now 5 will be called, therefore 5 will be pushed onto the same space, into the same cell where 4 was sitting previously, isn't it? And now at this point 5 is over, 5 is popped, and next 6 will be called, and 6 will be sitting in the same cell where previously 5 was sitting, isn't it? And now at this point 6 will be popped off, and at this point 3 will be popped off. Why? It is the last time you are visiting a node. See, whenever you visit a node for the last time, remember that it has to be popped. If you are not following this, please go back to the example where I have shown you how to analyze the space complexity required by a recursive function. Okay, now here by this time 3 will be popped off. Why? Because it is visited for the last time, right? And now 7 will be pushed. Now what is the least level, what is the least available level? This one only, right? Which means 7 will be pushed into this, right? And now at this time 7 is popped. Why? It is visited for the last time. And now 8 is pushed, 8 is visited, right? And at this point 8 is popped, right? Just observe here, 3, 7 and 8, they all occupy the same cell, one after the other, isn't it? Why? Because they are in the same level, 3, 7 and 8, and moreover 4, 5 and 6, they all occupy the same cell. The reason is they are at the same level. Therefore all the functions which are in the same level will occupy the same cell. Therefore number of cells required in the stack, that actually depends on the number of levels we have in the tree, right? Fine. Now 8 is over, then we are going to see 2, right? So by the time I reach here, 2 is going to be over, 2 is over, right? Then now you will reach 9. So what is the least available cell here? 9 will be pushed here. Now see this, 2 and 9 are pushed, are occupying the same cell. The reason is because they are at the same level. 9 is over, no, 9 is not yet over. Now 10 will be pushed, next available level is this, and then 11 will be pushed, 11 will be pushed here, right? And at this point 11 is over, 11 is popped off, and then 12 is pushed, and then at this point 12 is over, 12 is popped off, and 13 is pushed, and at this point 13 is over, 13 is popped off, and now at this point 10 is popped off, and at this point 14 is pushed, 14 will be pushed here, and now at this point 14 is over, 14 will be popped, and 15 is pushed, right? And now at this point 15 is over, and at this point 9 is over, isn't it? Now see this: 3, 7, 8, 10, 14, 15. 3, 7, 8, 10, 14, 15. These are all the function calls that are at the level 3. Therefore, at this cell 3, we have all those function activation records, right? Activation records are records are nothing but for every function call we push a activation record, that is also called as activation record. Okay. Now at this point 9 is popped off and then 16 will be pushed, right? And at this point 16 will be popped off, right? And finally 1 will be popped off. See this: at level 1, how many function calls we have? Only one function call. Therefore, inside this stack at the cell number 1, we have only one function which is continuously occupying this space, which is 1. And then at level 2, how many function calls were there? 3 function calls were there. And what are they? 2, 9 and 16. 2, 9 and 16. This is level 2, right? And at level 3, how many function calls were there? 3, 7, 8, 10, 14, 15. Therefore 3, 7, 8, 10, 14, 15, right? And then at level 4, how many function calls were there? 4, 5, 6, 11, 12, 13. Therefore, the total space required by this is, even though you had these many functions, all of them are occupying a maximum of 4 cells, right? But then this 4 is not a constant, that depends on how many what is the size of the n. So if you analyze this for 4, 6, 10, 20, 30 like that, you will find out that as the size of the given array is increasing, and if the size of the given array is n, then the number of levels required in the stack, this recursion tree, is log n plus 1. These many levels are required, right? And for every level we need a cell in the stack. Therefore, assuming that what is the stack size of the stack? Therefore, the size of the stack required to implement this is this much: log n plus 1. This is the size of the stack required. And assuming that the stack is going to occupy a constant amount of size k, the total space complexity required in order to implement this recursion stack is order of k into log n, which is nothing but order of log n. Okay, so this is the space required for this stack in order to implement this program. And what is the space required for the merge procedure? For merging, the space required is order of n. The reason is we are going to create a global array and all the merge functions are going to refer to that global array for the rough work, right? So for the stack, for the recursion stack, the space required is order of log n, and for the merge procedure the space required is order of n. Therefore, the total space required, the total space complexity for this merge sort algorithm is order of n plus log n, and the dominating term is n, therefore it is going to be order of n, right? So this is the space complexity that is required by this merge sort. And one thing you should observe is merge sort falls under a category called out of place algorithms. Out of place algorithms means we are not going to sort the given array inside the array itself. We are going to copy the elements onto some other array and then sort them and again bring them back, which means we need extra array in order to sort it. That is why it is called out of place. We are taking the elements out of their place and then sorting them. So this algorithm falls under the category called out of place algorithm. Okay. Now let's analyze the time complexity. So this is how you should analyze the space complexity, and the time space required is order of n. Now let's see the time complexity. How much time does it take in order to execute this program? So let us assume that given array is of size n. Then merge sort is called in order to solve merge sort is called to sort a array of size n. Then this one is going to be T of n. Let us say T of n represents time taken to sort the elements, n elements. Okay. Now we are going to divide the problem into two halves. How? by finding the midpoint and then the first half and then the second half, right? Then this one will contain half of the elements. Therefore, if the time taken to sort the n elements is t of n, then the time taken to sort n by 2 elements is t of n by 2, and time taken to sort the remaining half is t of n by 2, right? And time taken to merge is, if I have n by 2 elements and n by 2 elements, what is the time taken to merge total elements into one n list is order of n. This one we have already seen. If the total number of elements are n, right, and out of which I don't know how many, what is the size of the first list, and what is the size of the second list, but I am interested in finding the total size of the list. Let us say total size of both the lists put together is n elements, then the time taken to merge both of them is order of n. Then how can I write this equation? T of n is equal to 2 into t of n by 2 plus order of n, right? Which means in order to solve a problem of size n, we are dividing the problem into two subproblems of size n by 2 and then sorting them and then solving them, and then we are merging the result, right? So if you see this using the Master's theorem, the answer will be order of n log n. So whatever is the case, even if you give the sorted list or if you give the reverse sorted list, there is no best case and worst case for this. The time taken is going to be same. So both the best case and worst case is going to be n log n, which means if you give a sorted list, it doesn't solve faster, or if you give an unsorted list, it doesn't take longer time. Whatever is the size of the problem, it is always going to take n log n time, right? So that is about the merge sort. We shall see some problems on merging. Now we shall see merge sort in some other way. Now the question is this: given n elements, merge them into one sorted list using merge procedure, right? So let us say there are giving n elements. So I can assume that all the n elements are n lists and each list is of size 1, isn't it? So I am assuming that there are n lists and each list is of size 1, and you already know that every list of size 1 is already sorted, isn't it? Then I'll merge. So this we are going to do only two-way merging. Two-way merging means anyway we are going to take only two lists and we are going to merge them into one. Three-way merging is different. Three-way merging means I could take three lists and I could merge them into one list. So three-way merging and two-way merging both will have different time complexities. I am talking about two-way merging, which means two lists will be merged, right, like this. Now these two lists will be merged and then I will get a list of size 2, and again these two lists each of size 2 will be merged and then I will get a list of size 4, and then I will get a list of size 8, right? So on, I have to get the single list of size n, right? Then what is the total work done? That is what we want to find out. So at this level, how many number of elements are there? Totally n elements, right? And now all these elements have to be copied one by one to the next level, in which the number of lists will be n by 2 and each list will be of size 2, right? Therefore here and here totally there are n elements only. Now every element has to be taken from this list and it has to be copied to the next list. Therefore in order to cross from one level to next level, what is the total work done? I have to do n comparisons and n movements, right? Therefore it is going to be order of n. So to write n elements from here to here, it takes order of n time. And now there are n elements here and then n elements here. To write all these n elements from here to here, again order of n time, right? Then what is the total amount of time required is, or total amount of work done is, now just to cross one level the time taken is order of n. Then how many such levels are there? See this: to reach from size 1 to size 2, the number of crossings I had to do is 1. Why? Because it is log 2. Log 2 is 1. To reach from size 1 to size 4, number of crossings I have to do is 2, which is equal to log 4. To reach from size 1 to size 8, the number of levels I have to cross is 1, 2, 3 levels, right? Which is nothing but log 8, right? Therefore, to reach from size 1 to size n, the number of levels I might have to cross is log n levels, right? And in order to cross every level, the total work done is order of n. Then how many such levels I have to cross? Log n. Therefore, total time required for this problem is order of n log n. In fact, merge sort is working like that. Merge sort is dividing the problem into such a small level that every list will contain one element, and then once we get the list containing one element, we are going to merge them into list of 2, and then taking two lists of size 2 into list of 4, two lists of size 4 into list of 8. So that is how merge sort is working, and for this method the time taken is order of log n, right? We shall see one more question on merging now. Now the next problem is given log n sorted lists, which means the total number of lists present are log n, and each of size, which means every list is of size n by log n. So every list contains n by log n elements, and there are log n such lists. Now what is the total time required to merge them into one single list, right? Which means I have totally log n lists, and size of each list is n by log n. Okay, now I have to merge them all into one single list. Then what is the total time required for it? How to solve it is, if I have log n lists and each is of size n by log n, then what is the total number of elements? It is nothing but n, isn't it? Totally I have n number of elements. So at the lowest level I am starting with each list. So at the lowest level I am starting with log n lists, and now it is given, let us say these are all log n lists, right? And given that every list is of size n by log n, right? Now when I merge 2, then what do I get? I get a list whose size is 2 into n by log n, right? And when I merge two such lists, what do I get? At the next level I get list whose size is 4 into n by log n, right? And then I get 8 into n by log n, and finally I am supposed to get n, isn't it? How can I write it? Log n by log n. Then I am going to get all the n lists, isn't it? See, from this size n by log n, I have to reach the size of n. So how? By doubling them, right? Finally, how can I write it is, how can I get it is, in order to get a size of n, that is nothing but n by log n into log n, isn't it? So first it is n by log n, then it is 2 into n by log n, then it is 4 into n by log n, then it is 8 into n by log n, and finally log n into n by log n, right? So now look at the work done to move all the elements from one level to the next level. How many elements are there here? N elements. And how many elements will be there in the above level? N elements. So in order to move them from one level to next level, for every element I have to do one comparison and one copying, right? Therefore total amount of work done at this point is order of n. And again n elements are present here and n elements are present here. In order to move them from this level to this level, time taken is again order of n. And from this level to this level, time taken is again order of n. From this level to so on. So for every level, in order to move or climb above, the time taken is order of n. Then how many such climbings I should do? That is the point, right? So how many such climbings? Initially it is 1 into n by log n, then 2 into n by log n, then 3 into n by log n, 4 into n by log n, right? Then finally it is log n into n by log n, right? So in order to reach a size 2 into n by log n, I have to do one climbing, which means log 2 climbings, right? In order to reach this size 4 into n by log n, I have to do 2 climbings, which means log 4, right? In order to reach this size, I have to do 3 climbings, which means log 8. Therefore, in order to reach this size, I have to do log n climbings, right? In order to do one climbing, time taken is order of n, and there are log n such climbings, isn't it? Therefore, total time taken is order of n for one climbing. And how many such climbings I should, all the elements should do is log n climbings, right? Or the height of the tree is log n, and in order, at every height, in order to reach one height, one step ahead, we need to do order of n. Therefore, the total time taken for this algorithm is order of n into log n. Okay, fine. Let us say that n strings, each of length n. So there are total number of strings are n, and then each string is of length n, which means each string contains n characters in that. Then what is the time required to sort them into one list, right? Or what is the time taken to sort them? Here, in order to sort the strings, we are going to follow lexicographical order. Lexicographical order means the dictionary order, which means if I have these two strings, let us say AAB and AAA. How to compare them is, first I will compare A and A, they are same, A and A, they are same, B and A, therefore this is lesser, right? This is lesser, therefore this has to come in the beginning. So that is how the comparison has to be done. Now, if the first string is having n length and the second string is having n length, then how much time will it take for us to compare is, actually to compare this one with this one, I have to do, bitwise, this character wise comparing. Therefore, if the length of the string is n, then the time taken to compare two strings is going to be order of n. So remember that for one comparison, the time taken is going to be order of n. If they would have been numbers, if I have number 3 and if I have number 5, then how many comparisons do we need in order to find out which one is smaller? No, that is just order of 1. But here, in order to find out which one is smaller, I need order of n comparisons. Therefore, comparison is going to take order of n time. One comparison is going to take, right? Now let's see this. Now there are n strings. So let us say at this level we have n strings. So on, there are all n strings. So n strings are there, and the size of each string is n. Okay. Now initially we are going to merge these two. So we are going to do this sorting using a two-way merge. So that is also keep in mind, we are going to use two-way merging. Two-way merging means we are going to take two elements and merge them, two elements and merge them, right? So now initially the list contains one single element, and each element is nothing but a n length string, right? So in order to we have to compare these two, and then I'll get a list which is containing two elements in sorted order, right? So now the size of the list here will be 2, and now I'll combine two such lists, isn't it? These two will be combined into a list of size 2, isn't it? And now these two will be merged into a list of size 4, right? And then these two will be combined into a list of size 8. So on, I have to reach list of size n. Okay. Now let's see. In order to write all these n elements here, every element has to be compared one time. Every element has to be compared exactly once, right? So how many comparisons are required? Even though it is n by 2 or n, I don't care how many exactly, but one thing is for sure, every element has to be compared with some other element before you write it there, right? So at the first level, even if you could optimize the number of comparisons will be n by 2, order of n, right? Therefore number of comparisons are going to be order of n, and for every comparison time taken is order of n. Therefore for comparisons total time taken is order of n square. At this level, number of comparisons required will be n by 2, isn't it? Which means order of n, and every comparison is going to take order of n time, right? Therefore, it is going to take order of n square time in order to compare them and then find out which one has to be first and which one has to be second, right? And now we have to copy all of them here. What is the total size of the list? If every list is containing, every string is containing n elements and there are n such elements, then the total size of the list is going to be n square. Therefore, for copying, order of n square. For comparing, order of n square, and for copying, order of n square. So total time taken at one level is order of n square, isn't it? So after that work done, they all will be copied to the next level. At this level, all of them will be present, and again number of comparisons required will be again order of n, and for one comparison time taken will be order of n. Therefore total time taken for comparisons only is order of n square, plus moreover all the elements have to be moved to the next level. So how many elements are there? Order of n square, right? Therefore at every level order of n square work is going to be done. Then how many such levels are there? So you are going to, a size of, from one size we are going to 2, 4, 8, n. So if you see this, there will be order of log n levels. So finally the total work done is, there are log n levels, and at each level the time taken is order of n square. Therefore total time taken by this algorithm is going to be order of n square log n. This is the total time. Okay, fine. Let's see some questions which have been asked in exam about this merge sort. Question number 1 is, merge sort uses what paradigm? So options are divide and conquer, backtracking, greedy, dynamic. So we have seen that merge sort uses divide and conquer. The reason is we are going to divide the problem and then solve it and then combine the solution. Therefore merge sort uses divide and conquer. And the second question is, if for merging two sorted lists of sizes m and n, so two sorted lists are given, each of size m and n, right? Now we have to merge them. What is the total time taken? So we know that the total amount of time taken is, we have to, in order to combine them into one list, we have to compare every element at least one time and then we have to copy it to the next list. Therefore time taken is order of m plus n. Okay, this is provided that we have extra space. We should even have a extra space, otherwise order of m plus n is not possible. And next one is, they are saying that they have given an array like this. An array is this: 20, 47, 15, 8, 9, 4, 40, 30, 12 and 17. Now they are saying that it is being sorted. So algorithm is two-way merging. So they are going to use two-way merging, which means taking two lists at a time and merging them. They are going to apply two-way merging on this. Then they are asking what will be the order of the elements after the second pass. Second pass means second round. Okay. So if I use two-way merging, then these two will be merged, these two will be merged, these two will be merged, these two and these two will be merged. Then what do I get? By merging them, I'll get a sorted list 20, 47. By merging them, I get a sorted list 8 and 15. By merging them, 4 and 9. By merging them, 30 and 40. Merging them, 12 and 17. Right? Now I have got this. Lists of size 2 each. Initially lists were of size 1 and now again I will do two-way merging. These two will be merged, these two will be merged, there is nothing to be merged, therefore it will directly be written, right? So after first pass, this is the order I got, and after second pass, let's see the order. After second pass, this list and this list will be merged into a single sorted list. If I merge these two into single sorted list, what do we get? 8, 15, 20, 47. If I merge these two, what do I get? 4, 9, 30, 40. If I merge this, what do I get? 12 and 17, right? Therefore this is the answer. After two passes, this is the order in which we have the elements. right? So two-way merging is nothing but two-way merging, three-way merging, we shall see them later. There is something called as optimal merge patterns, we shall see that later, but I know it is simple question, therefore I solved it here. So these are the gate questions asked. One is merge sort uses divide and conquer, and other is this one, and other is this. Okay, so with the merge sort, you could even solve more questions using the what can I say, merge procedure, right? So they need not ask you directly only on merge sort, they can even ask you about the merging time and other things, right? So we shall go to the next sorting method.